channel. So today we will be discussing about the last problem of today's bi-weekly contest, escape the spreading fire. So we are given a matrix. Each cell can be either 0, 1 or 2. 0 represents an empty cell or a grass. 1 represents a fire and 2 represents a wall through which neither man nor fire can pass. Okay, so in one move, man can either move to north, south, or east or west. Basically, any of the adjacent cell which are connected, and also fire will also spread to its adjacent cell. So, for example, let's say at t like after 1 minute, what will happen is this fire will spread to this cell and this cell. Similarly, this fire will spread to this cell. Notice that this fire can't come here because neither fire or nor man can pass through the wall. So this fire will be only spread to this cell, and this fire will spread to this and this cell. So these all cells will be fired up after t equals to 1 minute, and man can move here if he wish to. Now what we have to find is we have to bring this man to this house which is like from 0 comma 0 to m minus 1 comma n minus 1, and we have to do this such a way that man should not be caught by fire. So like as we can see, the fire is also spreading, so whenever like man is moving, he should not be caught by fire. uh, and we have to find out whether it is possible or not. So we have to find out whether like how many like man can wait here and then start. Okay, so we have to find out how many minute man can wait here and then start so that it will not be caught by fire. So let's try to understand this with an example. So let's say this is the state. So as we know that one represents the fire and two represents the wall. So this things represents a fire. Okay, so these all things are fired up. So now this what happens at t equals to 1? At t equals to 1, this cell will be fired up because this fire and this fire will be spread to this cell and this cell will be fired up. Now what happens at t equals to 2? This cell will be fired up. At t equals to 3, this cell will be fired up. T equals to 4, this and this cell will be fired up. At t equals to 5, this cell will be fired up, and so on and so forth, right? So now let's say at t equals to 1, man start. So at t equals to 1, man start, and he moves from this to this cell. Okay, and like this cell will be fired up. Now at t equals to 2, man can move here. This cell will be fired up. At t equals to 3, man can move here. This cell will be fired up. And you can see that man can move all the way till here and he will not be caught by fire because all this are 2. So fire can't come from top. Fire will come one by one like this. Okay. So basically, man can reach to the uh, bottom cell without any issues, given that he starts at t equals to 1. Now, let's say he didn't start at t equals to 1 and he started at t equals to 2. So, what happens at t equals to 1? This cell will be fired up, right? Now, let's say he started at t equals to 2. So, then he moves to this, and then fire will move here, and then at t equals to 4, he moved to this. Fire will move here, and then he will move here, and fire will move here and here. Then he will move here, fire will move here, and you can now see man can safely reach to the end, and fire like he will not be caught by fire. So he can wait until t equals to 2, right? But let's say what happens if he wait 1 more minute. So previously he waited for 1 minute, and now let's say he waited for 1 more minute. So let's say he wait for 2 minutes. So what happens at t equals to 1? This cell is fired up. What happens at t equals to 2? This cell is fired up. Now man starts. So man starts from here and come here. But at this stage only, at t equals to 3 only, this cell will be fired up. So man will be caught by fire. So basically, man can wait for at max 1 minute, uh, and then he should start so that he can be able to reach destination without catching by the fire. Now let's look at this scenario here. Let's say if man waits for t equals to 1, like man waits for 1 minute. So in that case, this cell will be fired up, like this all cell are already fired. So this cell will be fired up. Now man starts. So man move to this, and then fire will move here. Again, man will be caught by fire. So he can't wait for 1 minute. Now let's say man start at t equals to 0 itself. So these all cells are already fired, right? So now this cell will be fired up at t equals to 1, and man will be here. Now t equals to 2, fire, this cell will be fired up, but man will be here. T equals to 3, this and this cell will be fired up, but man will be here. So now you can see the man can safely reach to the end without catching by the fire. So in this case, man can wait for 1 minute, but in here, man can't wait for any minute. He should start immediately. Like answer will be 0. But and let's look at this case. Here, no matter what, like at t equals to 1 itself, this cell will be fired up, and if man starts immediately as well, he will not be able to reach this destination without catching by the fire. So here, answer will be -1. Okay, so like this is the answer in this case. Basically, man can't reach the destination at all. So hope the question is clear. Now let's try to solve it. Now, as I always keep on saying, if the original problems looks little bit difficult, let's break the problem into smaller set that can be solved. So first, instead of solving how many times man can wait, like how many minutes man can wait, let's try to just solve, given a matrix, whether man can reach the destination or not. Let's not bring this t at all in our picture. Let's just try to find out, given a combination, like given a grid, whether man can reach destination or not. Okay, so let's try to solve that part of the problem. So let's say this is a grid. Okay, so now we just need to find out whether man can reach destination or not if he starts immediately without waiting for anything. So if this is the grid, what will happen is man is currently here. Okay, so uh, what happens at t equals to, so this all cells are fired up already. Okay, so what happens at t equals to 1? So t equals to 1, man will move to this cell. Okay, and this cell will be fired up. So you can see these three cells are now fired up and man is here. Now what happens after this? So this man has only one choice. He can move from here to here, like he doesn't have any other choice. These all are walls. But and at this stage this cell will be fired up because this is adjacent to this. So you can see these three cells are indeed fired up and man is at here. Now again here, man has one choice to go here. Okay, so he will go here, and this cell will be fired up. So you can see these all cells are fired up and man is at here. Now at this stage, man has two choice. Either he can go here or he can go here, right? So let's consider both of them. So like these are the two possible position of man. Okay, and man is at here and these all cells are fired up. Okay, now what happens? Like the next stage, if man choose this path, then he can come here only, and if man choose this path, he can come here. So basically, again, there is only one possible position of the man after this. So this position is the new man position, and after this cell will be fired up because this is adjacent to this. So you can see this cell is fired up indeed, and man is at this position. Now at the next stage, what will happen? Man has only one choice to go here, so man will come here, and this cell will be fired up. Okay, and what happens after this? Man has one choice to go here, and this cell will be fired up. So after this stage, man will be here, and this is already fired, right? So he can't actually move to the destination. So the answer for this would be no. So remember, we are just trying to find yes or no for a particular case. Basically, we are not worrying about time anymore. We just want to find out, with given a particular combination of grid, whether it is possible for the man to reach to the destination or not. So what we have done, we have just tried to simulate the entire process. We start the man from 0 comma 0. We move the man to every possible cell he can move, and we keep on incrementing the fire. at each move. So after this move, only this cell can be fired up. So we just fire up this cell, and only this, and man can only move to the this position. So man, like we just move this position to the man. Okay. So what we are doing is just simulating the entire process. We are moving the man one step to all possible combinations, and we are also moving the fire one step. Okay. And after this, we are just checking whether at the end either this cell should be fired up, or the cell at which man is present would be fired up. So one of these conditions would happen, or man can reach here. So based on this, we will just output yes or no. So what we have looked at is basically this. We are doing this thing. We start from 0 comma 0, and until we hit r minus 1 comma c minus 1, or everywhere is fire. Basically every cell is now fired. We just move all possible step forward. So basically, if man, let's say, and hypothetically, let's say the man is here, like, so we will try to move all the non-visited cells. So we will try to move man in this direction. So notice that this is the case where we have moved man to this direction. So basically here man can move to this direction or this direction. So we just moved man to these two directions. So move all possible step forward in from the previous positions, and then spread the fire with to one adjacent cell. Okay, and then just check whether R minus, like, just continue and until everywhere is fire, or you hit R minus 1 and C minus 1. So based on this, you will just return yes or no. So now we have an algorithm which will just tell us uh, whether it is possible for a man to reach a particular destination or not. Okay. Now how to solve the actual problem? So actual problem was like maximum wait time possible. Okay. So the solution of this is actually simple. What, let's say we have some grid. Okay. So we have some grid with us. Now if we say that, so basically we will start with t equals to 1. We will start waiting for 1 minute, and then we will check whether after 1 minute, whatever the state of this grid is, whether man can reach to the destination or not using this algorithm. Okay. Minute and still can reach the destination, then in that case we will try with 2. We will just move fire by 2 positions everywhere, and then we'll just apply the new algorithm on apply this algorithm on the new grid. And if again the answer is yes, we will try with 3. If again like we just move the fire by 3 positions in the original grid and then apply this algorithm. If answer is yes, we will try with 4. If answer is no, it means if man waits for 3 seconds, he can't make to the destination. So that's where we will just return 2, because 2 is our answer. Okay. So what is the time complexity of this approach? Basically we are trying every possible combinations, right? So let's say we try t equals to 3. So if we try t equals to 3, we need to move all the fires by 3 positions. That will require order of n into m time, right? Basically, we have to do a DFS or a BFS to move fire by 3 positions. After this, we will apply this algorithm, right? So this algorithm is also n into m. Basically, we are just traversing each cell exactly once. So so just to give you a brief intuition, if a cell is caught by fire, man will not visit to that cell again, right? So at max, everything will be caught by fire in n into m steps. So after n into m steps, there is no possible moves. So that's where the complexity of this would be n into m, right? So after selecting this, we are again doing an operation of n into m. So this will be the cost of checking one time. But we like time can also be n into m. Like man can wait for n into m time. Basically, let's say there is no fire in the grid at all, so man can wait for any number of time, right? No matter. So the complexity would be n square into m square, right? But uh, that will not pass, because n into m is around 2 into 10 to the power 4. So this complexity would not pass. Now what, like we have to reduce this. So we can't reduce this part, like checking whether a particular cell exists or not. So we need to reduce this part, right? So we are doing a linear search and you have to reduce the linear search. Again, only the first thing that should come to your mind is binary search. So what happens in binary search? You are given a search space, you divide the search space into half, and then you either go to the left or you go to the right. You don't search in the both the parts. So that's what binary search is. Now how we can apply here, let's say we check t equals to, this is t, so let's say we check t equals to 1 2 3 4 5 and so on. Okay, so let's say t equals to, at t equals to 5, uh, we check yes. So basically the answer is yes. Which means if man wait for t equals to 5 seconds, he can still make to the destination. So now if answer is yes for 5, would it make sense to check for 1, 2, 3, or 4? No, right? Because if answer is if answer is true for 5, it means man can wait for 5 seconds, 5 minutes, and still make to the destination. So it indirectly also means that if man can wait for 4 minutes or 3 minutes or 2 minutes, and he can still make to the destination, right? So that's where we will not check three. We will not check. We'll just skip the entire left part and we'll just check the right part. Similarly, let's say if the answer is no, basically man can't wait, like man can't wait for 5 minutes, because after if he waits for 5 minutes, he will not make it to the destination. So does it make sense to check for 6 7 8? Because at after waiting for 5 minutes itself, he is not able to make the destination, right? So at t equals to 6 or 7, fire will spread more. He will not be able to reach the destination anyway. So that's where you will skip the right part in that case and just check in the left part. So what we have done is basically we are just applying this algorithm. So for each, let's just zoom in. So for each, initially what we have said is for each y, or for each t, we will do is spread the fire by t minutes, and then use this algorithm. Use this algorithm to just check whether it is possible for the man to reach the destination or not on this upgraded grid. And if it is possible, then increment the y and repeat this step. Okay, if it is not possible, it means man can't reach destination if we wait for y minutes. So that means answer is y minus 1. So this is the brute way, but as we have seen, checking for every y cannot be possible because of time complexity. So that's where we have seen that binary search property is applicable here. So we will just apply binary search here, and instead of checking for each y, like instead of this part, we will just apply a check in the left. We'll check in the right, otherwise we'll check in the left. So hope the process is clear. Let's look at the code which will make it more clear. So what we have done is basically do a binary search from -1 to 10 to the power 9. So basically, like we are doing -1 because it is given in the problem that if nothing is possible, then we have to return -1. So that's where I start with -1. Now the inner part is very similar. Like we just check whether it is possible for the man to reach the destination after waiting for m plus 1 minutes. If it is possible, then just search the right part. Otherwise, search the left part. Now let's look at what how we implement whether it is possible or not. So whether it is possible or not, we are like I have implemented the structure my grid. We will look at what my grid is. Basically, my grid has a function which allow you to spread the fire by 1 minute. So we have to spread the fire by this many minutes, right? So what we are doing, we are just applying this many minutes on this new grid. So what we are saying, if fire has already spread to all the cells, just break out, like don't need to call the function again and again. But if fire has not spread to all the cells, then spread the fire by 1 minute. Now after this, we have spread the fire for this many minutes. So now we will just check whether it is like whether man can reach to the destination in this new grid or not. Right now, let's just look at how this my grid is implemented. We are taking in the initial grid, and then we are pushing in the queue all the positions which have fire. So basically, whichever cell has one, we are pushing that to the queue and marking it as visited. Now, how spread is implemented? In spread, we have to spread the fire by 1 unit, right? So let's say you have to spread the fire. Let's say this is the case. You have to let's just assume this is the case. So, and let's say you have to spread the fire by 1 minute. So what you will do, you will just try whatever new cell is fired up. So previously these two cells were fired up, right, already. So this is the new cell that was fired up after at this stage, right? So you will check what is the adjacent cell of all this cell of this cell, and you will just fire up those cell. And in next step, instead of checking for all these three, you will just check for this one, because this is the new one which was fired up. For the previous ones, you already have fired up all the adjacent cells, right? So you will just check for the new ones. So that's what we are doing here. Uh, we are like we are visiting all the neighbors of previous fired cells. Let's say, like whatever we have pushed into the queue, we are just iterating over them and visiting all their neighbors. And if they are not visited and they are not fired, uh, then we will just fire them up and add it to the new queue, like new fires, and just visit them up as well. At the end, we will just mark this fire as new fire. So basically, fire stores the last fired cells. So in this case, in this scenario, fire will, like at this point, fire will store this cell, this particular cell, because this is the new cell that's fired up. After this stage, the fire will store this particular cell. After this stage, fire will store this particular cell, and so on and so forth. So once you have this fire, uh, like basically you have just spread the fire by 1 unit. So that's what this spread command is doing. Now we just need to find out, like this is the part where we have like implemented the first algorithm, basically whether it is reachable, like whether from this grid it is possible for the man to reach the destination or not. So what we have done is, we have maintained a queue of the position of the man. Initially man is at 0 0, and then what we have done, we have tried to move man in all the possible neighbors. If it is possible for the man to move, basically the next cell is not fired up and it is not visited already, then we will just move the man. So basically the new position of the man will be this current next cell. So this is the, like that's why we are just pushing it in the new queue. And after we have iterated over all the possible uh, previous positions of the man, we will just assign this new queue. And notice, before incrementing the man's position again, we will spread the fire by 1 unit. Okay, so that's what we are doing. So just to reiterate, initially, like this is the part where we are just checking whether it is possible for the man to reach the destination or not. And how we are checking that? We are uh, incrementing the man's position one by one, and at the same time we are incrementing the fire position one by one. So we are spreading the fire by 1 unit each time we move the man by one position. And at the end we are just checking whether man reaches the destination or not. So if man actually reaches the destination, we will just return true. If this entire process ends and man is not able to reach destination, we will just return false. So this function is doing this part. Now uh, we have already seen that we can apply binary search. We don't need to wait for like t equals to 1 and then t equals to 2 then t equals to 3. We don't need to try all possible checks. We can apply binary search. So that's where we are applying binary search here and checking the whether it is possible for the mid, like if we wait for m plus 1 minutes, whether it is possible for the man to reach destination or not. if it is possible for the man to reach destination, it doesn't make sense to search in the left part of the array, because all those, if man is able to reach destination after 5 minutes, he will be able to reach destination if he waits for 4 minutes or 3 minutes or 2 minutes. So that's why we are only checking the right part of the array. We are incrementing the left, and else we will just check in the left part of the array, because if man is not able to reach destination after waiting for 5 minutes, he will not, definitely not be able to reach destination after 6 minutes, 7 minutes, and so on. And after, like, the what is valid function is doing, it is very simple. It is just spreading the fire by this many times, and just checking whether it is possible for the man to reach using this new grid or not. So hope the solution is clear. The main part of the solution is to implement it in a quicker way. So this spread function is something that will help in this solution. So I will encourage you to code this solution out yourself after watching the video. And if you face any difficulties during the coding, feel free to pin your code below. I will be happy to find any I'm happy to find any edge cases that you were not able to find. And do check out other videos. I will see you tomorrow. Thank you.